take my card and we can follow up.
Okay, everyone, we're going to start in about 30 seconds.
Yeah, I'm on. Oh, I didn't have to do anything. All right, it's 11 o'clock, so we're going to get going. So we're going to take about an hour and walk through some of the programming within ROS. By no means will you be experts after this 1 hour. You may not be able to do very much, but at least you'll have an idea of how to get started and where to get help. Let's see. So we talked about ROS being 4 things, right? It's plumbing, tools, capabilities, and ecosystem. So those themes are going to come up again. There we go. So here's our agenda. We've gotten through 3 or 4 bullet items, but now we're going to talk about what we're calling ROS basics. And even that, doing ROS basics in an hour is a little bit tough. So, but we're going to cover those 4 things, and the 5th thing is installation. Everybody wants to know how to install ROS, so we'll go over that. It's not too bad. So. More audience questions. Woohoo! Who's familiar with Linux or uses Linux? Yeah. See, Andrew, you putting that your SIC tool and on the key is going to be very valuable. Okay. So ROS is a lot of command line terminal stuff. It's a little bit scary, but there are a good number of people who look like they're familiar with Linux, so hopefully not so bad. Anybody who's not, just realize that ROS is built by a bunch of programmers, and we don't need GUIs at all. If we could just interact with a text prompt, we'd be happy. Who is familiar with C and C++ programming? I guess I should think about where I am. I'm sure. You go to a Midwest city in the middle of a farm belt and you ask that question, and no hands go up, and it's a little bit sad. But how about Python? Lisp? Way to go. They're always proud. Lisp programmers are always proud. I have no clue when it comes to Lisp. What about Ruby? Good, good. All right. So definitely a lot of C and C++ and Python programmers out there, which is good because the 2 best supported languages for programming in ROS is Python and C++. So you're all good. Who is familiar with the term middleware? Okay, that's the sticking point. If you're familiar with middleware, a lot of the hard things in ROS seem obvious. So I'm going to spend a good amount of time working on kind of describing the middleware part of ROS. Because if I can get you over that hump, then making your robot move and downloading packages and doing the stuff you're probably really interested in would still take some effort, but at least you won't get hung up on the fact that 2 software processes magically talk to each other. Do you have a question or? Sure. I don't know. I mean, there is, right? There's a spec for ROS. Yeah. The answer is yes. Like, because ROS is really just a specification of, how you make 2 software processes talk to each other, theoretically any language can be supported, right? They're called client libraries. There's a Python client library for ROS. There's a C++ Python or C++ client library for ROS. But those are, you have to be a pretty good programmer to make one of those. I don't count myself among that level of programmer. But yeah, any language can actually talk, which is why Lisp is on there, because nobody understands Lisp. But you have to be a really good programmer to understand Lisp. And if you are, then you can create a Lisp client library for ROS. But it has to come from somebody who has that interest. JavaScript, I don't know if there is one. I mean, I'd be surprised if there wasn't somebody starting one. I didn't hear that last bit. Oh, yes. Does the hardware actually support that? And I don't know enough to even give a reasonable answer. So I'm going to punt on that one. But if you want, you can come up and talk to me later. I can maybe put you in contact with people who can. All right. I think I might have mentioned this, but good thing I put a slide in here because I may have forgotten. All the material that you're going to see, right, it's going to be on your USB key. So this is all the material if you fill out the eval. I did a great job, right? I'm doing a great job. No, fill out the eval, be honest, and then you'll get these slides. But all of this content and way more is available free online. So we're going to hit some exercises and some tutorials. There's way more online. There's the link. The material that is online covers about 2.5 days of in-class teaching and labs. So there's really a wealth of material. We give this class, this 2.5-day class, about once a year. And you have to pay for it, but you come down to Southwest Research, and or if you're a big enough company, we'll actually come to you and we'll give this class over 2.5 days. All the material's free, and we tell everybody, even though they want to pay for it, that it's free. So if you don't have big training budgets, just go on the web and work through it. You know, I like to think I provide some entertainment value, but really it's all available. So we do have to thank the ROS Industrial Consortium. They funded the development of all this curriculum. And then when we said, hey, could we just post it on the internet for free? They didn't say no, which is amazing when you have 20 or 25 large companies who think, you know, even their letterhead is proprietary. So I'm really happy that they did that. That's, you know, it shows the kind of companies we're dealing with, that they have foresight and they believe in the ecosystem, right? Okay, installing ROS. All right, on your USB key, there is a virtual machine. How many people know what a virtual machine is? Awesome. Don't even have to describe it. All right. If you download VirtualBox, which is free, you can run the virtual machine. It's pre-installed. Another question? I don't know. I guess I didn't ask the question who uses Windows, but I got one. Is there somebody else that wants to put up their hand? That is true. That is true. And I'm only half joking. So on my machine, I run Windows, and then I have about 8 VMs that are all Ubuntu. So I'm not sure if I gained supporters or lost a bunch, but the answer is yes. I'm reasonably certain you can download VirtualBox. There's instructions right there. The first link will tell you how to configure VirtualBox and start it going. Everything's installed. Even our favorite tools are installed, or well, mine and Christina's favorite tools for working in ROS. So it's the easiest way to get started. And you don't know how many people send me emails, say, hey, I've got this question, and I can see their command prompt. And I'm like, oh, you're using our virtual machine. So some people never quit. They just download the virtual machine, and that's how they develop in ROS. You can also do it natively for the purists out there. But there's, when you do that, you have no virtual machine overhead. Woohoo! But you also get better hardware support. So everybody wants to connect the ASUS camera, the Microsoft Kinect camera, to ROS, because really you can do some amazing things with a $150 sensor. Unless you have the right kind of virtual machine backend, so VMware tends to work. But if you don't have that, the only way to be able to talk to a sensor like that is by doing a native Ubuntu install. So we also have a bunch of old laptops at Southwest Research that are all, Ubuntu machines now because we can install natively. If you don't want to use any of that stuff, you can actually, and you really know what you're doing, you can go to the bottom link, and I'll show you this link. And it'll tell you how to install ROS from Debian packages, so like binary downloads. It's pretty straightforward. Okay, so installing ROS packages. A package in ROS is really just like a nugget of functionality. There are packages for visualizations. There are packages for logging. There are packages for path planning. So a package in ROS is really just a nugget. Typically, there's one developer or maintainer that's kind of creating that, they have documentation associated with them. So there's probably hundreds or thousands of packages in ROS. Thousands? Somebody should nod. It's definitely thousands. We have, within ROS Industrial, we have more than 10, but less than 100. We support so many robot configurations. That's a lot of our packages. It's not all programming necessarily. So when you want to install a ROS package, you have two choices. If you're like me, you want to do the easy thing, which is install the Debian packages. These are binary downloads. It's nearly automatic. I'll walk you through doing it pretty easily. If you aren't hardcore programmer, this is where I would start. The additional benefit is they're stable. Which means like nobody's breaking these Debian packages. They build them once, they put them someplace, and that's always going to continue to work. And it's very easy to use. If you're hardcore, how many people in here are hardcore programmers? Come on, there's way more than that. You do it from source, because that's how it was meant to be done. You get access to the latest code when you do that. That's good and bad, because the latest code has the best features, but also the most bugs. But if you're hardcore, you just deal with that. Most of the source repos for ROS are hosted at GitHub. There's more effort to set things up and build from source. I'm not going to go through that because it's time consuming. And like I said, I recommend doing it from Debians. And yeah, they're unstable. The cool thing is you can mix and match. You can download some stuff from source, and you can download some stuff from Debians, and that stuff knows how to work together within ROS. There's no real tricks to that. That's not 100% true. There are some times when that breaks, but it's mostly true. All right, how many people are familiar with apt-get? Okay, all right, well, only about half. So you can install any ROS package from the command line. You do that using a program called apt, and it's one command line call, sudo apt-get install, and then you give the name of the package. And all ROS packages are named ROS-distro, so that's like a version. ROS versions are like Groovy, Indigo, Jade. And so if you do ROS-Indigo and then the package name. The trick is you need to know the package name. Luckily, if you just know, hey, I want to do like navigation, you type NAV and then you hit tab a couple of times and it pops up with a list for you. So then at that point, you only need to know how to read. And I'm presuming that most people in here can read, so we would be good. What this does is it downloads the official version of that package from the OSRF servers. OSRF is kind enough to host all of the ROS packages that you build through their system. So all of ROS Industrial packages are built on OSRF servers. This is true of many universities around the world as well, and even some companies build their stuff. I'm not sure if Fetch builds their stuff on OSRF servers, but and then if you want to remove a package, it's just as easy. You do sudo apt-get remove, and then that name, and it's gone. Okay. Who's excited about seeing a package install? All right. Thanks for humoring me. I appreciate it. So I'm going to open up the virtual machine, or click on the right one and then open it up. The password for everybody, because you get this. It's ROS Industrial all underscores or all lowercase. Write that down because your virtual machine will have the same password. All right. It's ROS Industrial, all one word, all lowercase. No hyphen, no nothing. All letters. All right. Let me go find this guy. Okay. I lied to you. Before I'm gonna show you an install, I'm going to show you surfing the web, which is even more interesting, right? All right. So where am I? I'm on wiki.ros.org. Okay. So this is the ROS wiki. It's a lot of user-generated content, but there's a lot of information. You know, you have install instructions, which we're going to go through. Then you have tutorials for getting started, and they're different than the tutorials that we have as part of the ROS Industrial training. I would recommend you look at both because the approach is different, and some people like ours better because they learn that way, and other people like these tutorials better because they learn that way. The tutorials on ROS tend to go into more of the details of what you're doing. Ours just kind of gloss over it and say, you want to learn how to make two nodes talk to each other. Here's how you do it. So we kind of gloss over. I actually like the ones on the wiki better, but people generally don't pay for those. So, all right, so we can go to install. The current version of ROS is Jade, actually, but the VM that you have is installed with ROS Indigo, which is their LTS or their long-term support version of ROS. So we're going to go there, right there. So you select your platform. There's Ubuntu is obviously the one that is, well, it's not obvious, but Ubuntu is the one that is well supported. Then you look at some of the other ones, OS X if you're a Mac person. Android, I have no experience with any of these, by the way. I only use Ubuntu, and I only have VMs for Ubuntu. But you can use other platforms. There is better support for ARM, Ubuntu on an ARM processor. I don't have a lot of experience there, but I know that there's a good community behind it. So if you go to Ubuntu, which is what we're working on, you can walk through. It's not, I don't know, it's maybe like 3 or 4 pages to get ROS installed. Anybody who's done a lot of open source development should really appreciate that. Because sometimes the install process makes you want to kill yourself. And this is really not that bad. So, all right. So we're going to now we're going to install a ROS package, right? So everybody remembers that we had to type, or maybe I already typed it, sudo apt-get install ROS Indigo and let's just do desktop. Okay, so say I wanted to install all of, well, not all of ROS, but the main parts of ROS. The thing you want to install is sudo apt-get install ROS desktop, and then there's ROS desktop full. Those are the big, they call meta packages, which essentially take all the packages you normally use and put them in one install. The instructions over here on the right, this is pretty much what they're telling you to do. But, you know, once you do that, you may not get everything you bargained for. So maybe you want to install calibration packages. ROS install, Indigo, nope, don't show me all. Calibration messages. Because you know you were at a party and everybody was talking about programming in ROS, and somebody said there's this calibration messages package. So you left the party and you went home and you're like, I am going to install this, right? And so this is all you have to do to install it. You guys don't have parties like that? Well, I thought this was the right room. I mean, really? Okay, so it's going to ask for your password again, which is ROS Industrial, all underscore, or all lowercase, all letters. It's going to say install without verification, which I'm sure is, oops, did it? There we go. There we go. And it's done. That's it. So you just install the ROS package. Say you were at a party with a bunch of cool people and they were talking about the ROS Industrial package, because that one's awesome. You just have to do ROS Indigo Industrial Core, and we can install that. It's actually already installed, so I'm not going to run it. Here's a helpful hint. Say you downloaded the wrong package. You can easily remove them, although you don't have to, by doing ROS Indigo calibration messages. So the thing that I just installed, I'm now going to uninstall. Say, do you want to do this? Yes, I do. Done. So the hardest thing about doing this is knowing what package you want to install. Once you know that, you can install it, you can remove it. I chose this one, not because it's particularly cool, but because I know it won't mess with anything installed on the VM. So you type out enough, and then you hit tab, and you see here it says display all 900 or 294. I can say yes, and then it'll go through the list of them. These are all the packages for Indigo. It's worth pointing out, I said there were thousands of ROS packages, or on the order of that. These are only the ones that are built as Debians that you can get this way. So there's a lot that are just built as random GitHub accounts, or maybe not so random. Yeah, so sometimes you don't have a choice. You have to download from source. Any questions about that? How many? So actually, I don't actually know all the details. Every so often, yeah, every so often it pops up over here and it says, hey, you want all these updates? And I download them. Once you're installed, they track it, right? Let's see. I had a thought and then I lost it. How many people have installed ROS? That was it. Okay. How many of those people who couldn't actually do it? That's good. All right. I mean, because the hope is that is easy. Because if you can't do that, then you'll give up immediately, right? Yeah, and you'll see that very poor performance. It's not so bad when you're just writing nodes that talk to each other through ROS, but if you're doing graphics, go out and pay for VMware because it has really good 3D graphic support, which is really. I don't know. I haven't had that problem. Okay. Let's see. So no other questions on installing, I'm presuming? We're good? Yeah, you can do that. You can install them separately. That's why it's ROS-distro, so that you can keep them separate. And then the only trick then is setting up your environment. When I open a terminal, it does need to know what version of ROS you want to run in that terminal. There's hacky ways, which is the way I use, which is just modifying my bash RC file to set up that environment correctly. There's also, if you're really good at the terminal, you can just do it every time you start it up. I will say in the ROS Industrial Training virtual machine, which is what is on the USB key, we hide a lot of these details from you. We do that kind of on purpose because a lot of people have trouble getting up and started, getting their environments all set up. I have some tutorials that you should look at, but just know that we're doing that in the background. Okay. I have not. If the question is if I used Rviz with Ecto. Is that the question? Yeah. Yes. And I have not. I don't have much experience with that. All right. One thing I think you guys should look at is these additional tutorials. One is Catkin, which is the build system for ROS. It's kind of a small miracle that you can build a robotics package that depends on a bunch of packages all distributed all over your machine. That is done using something called Catkin. So if you're building from source, you have to understand how to use that tool. And if you want to do source installs, there's a link right there as well. All right, so now we're going to talk about ROS plumbing. How many people are familiar with inter-process communications? Does that make sense? So when I started to program, you wrote one long monolithic main, and if anything had to communicate, you just made a global variable and then you just put it there. And everybody should laugh because that's horrible. You don't do it that way. But the ROS is set up. I talked about having these different processes. So you can write a process in C++, one in Python, and they can talk. That's the plumbing, right? Those processes in ROS we call nodes. And the way they talk is through something called a topic, right? And the way this works is you have a publisher node, which there's the arrow. A publisher node starts up and it advertises a topic. Sounds just like what it is. It tells the world, in this case the world is ROS master, hey ROS master, I want to advertise this topic. And then you have a subscriber. And the subscriber wakes up, it's its own process, and it says, I want to listen to a topic. And so it goes to the ROS master and says, do you know anybody who's publishing this topic? And the ROS master says, yeah, I got this publisher over here. Here's where he is. And then the publisher and subscriber then make a direct connection. So they take this ROS master out of the loop, and then they make this direct connection between each other. Now I can take data from my publisher node and send it to my subscriber. So topics are really channels. They're communication channels. And messages flow along these channels, but they're really the data types associated with those channels. So I can only, for a topic, I can only send one type of message. And then different topics, but I can have different topics. They all use the same message. So maybe I have, I don't know, 2 cameras, and they're each publishing an image. And I have an image processing node that subscribes to both of those nodes, or both of those topics. And it can receive both. So topics are for streaming data. You know, sensors produce streams of data, and then nodes just wake up and connect to those. There's this idea of multiple publishers and subscribers. So many nodes can publish and subscribe to the same topic. So for example, a camera driver can produce it produces one topic with an image, but then there can be multiple nodes that subscribe to that. So you end up with 3 links between your one camera node and the 3 different nodes that want to subscribe to that image. So each topic is a stream of messages sent by publishers and they're received by subscribers. Yeah. I don't know. Okay, get me offline, and I'll see if maybe Christina knows. I don't know where she is, or maybe somebody else does know the answer. It's completely asynchronous, so it's fire and forget. So the camera node in our example doesn't know who's receiving its images, or well, doesn't know that they have received them. There are synchronous forms of communication. There's tutorials for those, but we won't talk too much about them. So publishers don't know if anybody's listening. Messages may be dropped. Your system just has to be tolerant of that. When a message comes in, it's all event triggered on the subscriber side. So you basically say, when you get a camera message, run this function. And then the function is where the magic happens. Whatever your node does, it does in that function. Typical uses are sensor reading, camera images, various forms of I/O, inputs and outputs, open loop commands. So I may just publish to a robot, go to this position, but I don't really check if it actually gets it or if it even performs that operation. That's not the desirable way to do it, but sometimes it's quick and dirty and works. Okay, I said that topics are really the channels, and then the data types that go along those channels are called messages. Messages, there are tons of messages out there. And this is kind of how things get standardized. So there's a message for images, right? If I'm a camera, I'm going to produce image messages. And so when you're creating your ROS system, you generally are looking for these standard messages because that ensures you'll get interoperability, right? If you're doing something really special, and sometimes you do, you can actually create your own message types and create your own ways for nodes to communicate. So in this case, we create a path position message, which contains an X and a Y location and an angle. And I'm sure there's a standard message that has this, and it's not called path position, but it's just for demonstration purposes. Okay, be prepared to have your mind blown. Let's see. 1.6. All right, so that is probably vanishingly small for you guys. Can you see that? Nope. Bear with me. Let me. Edit. There it is. Oh, there we go. That's perfectly readable. It's not going to work for the big one. Okay. That may work. Okay, so here's our message definition for a message. Our message has a header, which is like a sub-message type. So you can kind of embed messages in other messages. So a header includes things like timestamp and frame name and a couple other things. A lot of messages have headers. And then we're passing an X and a Y angle. Here is our subscriber node. So this is the actual code. When we compile, this is what we compile, this code. It's a main, right? It initializes ROS. This is what kind of sets up the node and tells the ROS master, hey, here's my name, and I exist. We create a rate object, a publisher object, which includes an advertise right here. Right there. We're advertising the topic position. So we started up our node and we created a subscriber and we advertised that subscriber. Or I'm sorry, we create a publisher and we advertise that publisher. And then down here, we just have a while loop where we're going to publish a bunch of messages on that topic. So this is the magic. There's no magic there. It just randomly assigns angles and headers and stuff like that. So that was a publisher. That they publish topics. Then there's subscribers. These guys subscribe to topics. It's a little bit simpler, mostly because this node is really simple. Again, we initialize the node, so we tell the ROS master who we are and that we're a node. We create a subscriber, and part of the arguments to that subscriber is a method that I'm going to call when that message comes in. So it's all event-based. When somebody publishes on a topic and sends out a message, the subscriber will receive it, and then it will execute this callback method. And the callback method is defined up here, and all it does is print it out. This ROS spin is very important. If you don't call this, it's not going to process incoming messages. So a lot of times people will forget this and they'll start their publisher and they're like, I'm publishing, but all my subscribers don't receive anything. It's 9 times out of 10, you don't have the ROS spin method. There's magic going on in there that allows all that to happen, but just know that you have to have it. Sure. Yes, and I should be clear, I like ROS Industrial. I'm biased. But all the stuff I'm showing is just pure ROS. And you can do it in anything. Okay, so we have we have 2 nodes. We have a subscriber and a publisher. We're publishing a path position type message. And basically in our publisher, we make a random one, send it out, and in our subscriber, we receive that and print it out to the screen. The publisher also prints it, so we know what we're looking at. So this is going to take multiple terminals. You don't really have to do it this way, but I'm doing it just so people understand what's going on. So the first thing you start is a program called ROS Core. This starts up the ROS master and maybe a couple other standard nodes. This is what facilitates the communication. Then the next thing I'm going to do is I'm going to do ROS run. I'll type this one out. So we do ROS run, which is a command line tool. You have to give it a package name. So the package we're working on now is lesson, simple topic. And then you have to give it a node name, which is simple. And if we hit tab, we'll actually get a listing of them. Simple publisher is the one we want to run here. So we started it up, and you can see it's starting to publish a bunch of messages, or at least it's printing it out to the screen. Now I'm going to run the same thing except the subscriber. So ROS run lesson, simple topic, except it's the simple subscriber. And now every time it receives that message, it prints it out. And just in case you don't believe me, because maybe you think I lie a lot. Oh well. There we go. Nope, I pulled off the wrong one. That's nice. Okay. So you can see over here, we're publishing out and then we're receiving on this end. And let me make that bigger so you can. So the left side, or your right side is the, or your left side is the publisher, your right side is the subscriber. So you can, if you were fast enough, you'd notice that we actually publish the message before it's received on the subscribing end, okay? So I'm gonna run a tool called RQT Graph. And what RQT Graph does is it goes out and it sees what ROS nodes do you have running and what connections do they have to each other. Okay? So to highlight things, you can see my simple publisher, right? They're publishing a topic called position, and simple subscriber is receiving it. Pretty straightforward. This is the simplest kind of ROS system you can bring up. And this is middleware, right? This is the plumbing portion. You got a question? Yeah, it was like running one program and then another program, and then they make a connection and they send data between each other. So the question is, when the publisher's up and it's publishing messages, but nobody's there to hear them, what happens? Kind of like that joke, right? No, they don't go anywhere. They essentially only get sent out if there is somebody to receive them. Now your program doesn't know that. It executes the same way. It's just it calls the same method, but in the background, nothing actually gets sent out. Yes, yeah. So it would be, the ROS master would, the question was, does the ROS master kind of intercept these communication lines? It helps facilitate the communication and set it up, but it doesn't intercept them because then it would become a huge bottleneck. So the question is, if you have multiple subscribers to the same topic, does the data get duplicated? And the answer is yes. You get multiple copies. Yes. Yes. This is not a shared memory transport. It actually uses TCP underneath. Yes. So it's getting down into the weeds, but that means if you publish lots of images to lots of nodes that subscribe to them, you're making lots of copies, and there can be a performance hit. Okay, I'm gonna move on because I want to show you something that's a little bit more awesome than text flying by on a screen. I got to kill all this so I can show you the next thing. The next thing I want to show you. So, there were a good number of people who are interested in manipulators, and one of the cool libraries within ROS is Move It, and it's also one of the easiest to set up. So I'm going to kind of go through some of those details. I'll skip through a couple of other exercises because I don't think they're as relevant to this group. Just so you know, there are synchronized messaging services that can go on. Those are called services. Instead of typing in multiple terminals, a bunch of executables, there's this launch system for launching everything from one terminal. There's a way to share data among nodes. It's called a parameter server. And there are lots of command line tools. I showed you the RQT graph, which brings up a GUI, but there are lots of command line tools for interrogating a ROS system. So I recommend everybody look at all of these tutorials. We talked a little bit about ROS tools. I'm just going to gloss over these, but the big one is Rviz. I think you probably saw some of that if you went in the back of the room. The Turtlebot had up Rviz. It's an extremely powerful tool for showing, a lot of people look at it and say, oh, I can understand what the robot's thinking because I can see in one spot all the data, all the images, all the geometry that the robot's aware of. It's very powerful. As part of our ROS Industrial labs that we have for our training courses, we have a pick and place tutorial. A lot of people want to do pick and place applications. I recommend you go out and you look at this demo because the cool thing is you can run it completely in simulation. We simulate point cloud data, we simulate robot motion, and you can see, you know, a full ROS system. You can imagine how many nodes you might need to do a pick and place system. But you can do all that in simulation without access to any hardware, which is nice. It's low barrier to entry. And when you get those slides, there are the instructions for actually starting that guy. Yeah, but ROS Industrial provides a lot of those. But if you have a custom robot, that is true, and I'll get into that pretty quickly. Okay, what's very important in ROS is, one of the things that I think they've done well is they've identified libraries. So a lot of robotics libraries in the past created their own libraries for doing transformations. You know, who doesn't want to program their own quaternion math? No, okay. But what ROS does really well is they say, okay, we're going to go use eigen because they're the best of breed when it comes to doing, you know, geometric transformations. We're going to use Boost because they're the best of breed when it comes to doing things like smart pointer management. PCL and OpenCV, those are 3D and 2D vision libraries. And then MoveIt, which is a path planning library for all robots really, but we generally use it for manipulators, right? So ROS is more than, it's got all these libraries underneath it, and some people forget that when we talk about it, but it's really true. It's built on a lot of libraries. All right, you were asking about how to actually set up a robot. One of the things you need is the geometry of your robot. Why do you need this? Because ROS is aware of geometry. It can do things like collision checking, but in order for that to work, it has to know what your robot looks like. So that's like step one of setting up a manipulator. It's create a URDF. URDF stands for Universal Robot Description Format. And it's neither universal, and we use it to describe lots of things that maybe aren't considered robots. So I don't know that the name makes sense. But you can create a URDF in two ways. By hand, if you're awesome, you can do that. And you like XML editing by hand. Or you can download your robot into SolidWorks, and there's actually a SolidWorks add-in that will take your model, you answer some questions about it, you identify where the joints are, where the links are, and you export a URDF. And it probably exports a URDF that's maybe 90% correct. Sometimes you got to go in there and edit. You know, it'll do things to the 10th decimal when really, you know, it's 0. It's not a very small number. It's actually 0. So yeah, it rounds near 0 offsets. You have to do that by hand. There are two things you got to provide to a URDF. Visual models, and that's the pretty picture. So when you see the Rviz visual, and you see really nice smooth angles, and it looks like the real thing, those are your visual models. But you don't want to use those for collision checking because that's really time consuming. So the other thing the URDF needs are collision models. And those are typically really rough, sometimes they're just geometric shapes, or they're convex hulls of the nice, pretty visual models. Everybody understood that difference, right? Okay, so once you have a URDF and you've generated your visual models and you've generated your collision models, you then have to configure a ROS system. And think about this. You're putting together this arm. It's got this complex geometry, and it's got forward and inverse kinematics that are completely unique, right? No other robot arm has that kind of information. But you want ROS to understand all that. So the way we achieve that is really by configurations. We create configurations of robots. And we do this for ROS Industrial, so you guys don't have to. But I'm kind of walking through the steps so you can do it for your own robot if you had a custom robot. So you have to create configurations, and the way to do that is use the Move It Setup Assistant. And it's pretty straightforward. Let me see how we're doing on time. You said I could take 10 extra minutes, right? We good, Andrew? All right. I'll do this because it's worthwhile, and I can run through it quickly. Okay, so the command is ROS launch, move it, setup assistant.launch. And the tutorial online has all these laid out for you. So it's not so much, you got to get that right. Uh-oh. There we go. This is what happens when you run too many ROS windows on your robot. So it brings up a nice GUI. This is like a wizard, except we didn't want to call it a wizard because that's Windows. Dave Coleman actually created this, and he felt like Setup Assistant was a better name. So you can create a new Move It configuration. It asks you for the URDF. So we're going to go to training, supplements, source. These paths don't mean anything, by the way. They're just where we go. Eventually, we get to a file that has a .urdf extension. This is an IRB 2400, so it's an ABB robot. It's just a URDF. We hit open. Just in case you are curious, this is what a URDF looks like. Either this one was manual or this one's automatically generated, but it just has a bunch of XML that defines collision and visual links, and then joints between them. So that's the one I'm going to load. Over here, it brings up a picture. That is an awesome industrial robot, right? Yeah. And then we just walk through the steps. The first thing you got to do is figure out which links are in collision with themselves. This is important. If you have a robot and it can run into itself, it needs to know that. So this is what this step does. And it basically goes through very quickly and looks for all the collisions between links. And if two links never collide, it actually captures that information because then it doesn't have to check for collisions. Collision checking is very expensive. You can set up planning groups. So if we look at this manipulator, we'll give it a name. You can add joints. And when you click on joints, it just adds them. And what we're doing here is we're saying, okay, here was the geometry, right? This is what the geometry looked like. And now I'm going to tell you when I want to use your arm and move it, here are the links that I'm talking about, right? And so we just select all the joints. And it complained. Oh, you know what it is? I skipped the virtual link. So I'm creating a virtual link to tie the robot to the world. And then I think if I go through planning groups, this will work better now. Add group, manipulator, add joint. Oh, I'll call it manipulator 2. There we go. Save. There we go. So we have manipulator 3. Now I can use that for planning. right? So I can do forward and inverse kinematics on these joints. That's all supported by the MoveIt library. And I can do path planning and all this stuff just by defining, 3 or 4 things using this setup assistant. At the very end, you actually generate a package that has all this information in it. Somebody came up and they talked to me about the navigation package, which is kind of hard to set up for a mobile base, which is why I'm not going over it here. Manipulators are much easier to set up because we have the setup assistant. So I recommend, if you're going to start with ROS, maybe start with a manipulator, even if that's not what you're going to program, because it is really easy to set up. So I'm going to cancel out of this and then go back to this guy. Okay, let's skip through that. Motion planning using MoveIt. So once you've created a MoveIt package for your arm, you then want to do motion planning in it. And that is where the fun stuff happens. Whenever you create a package, I created one called IRB 2400 Shaun MoveIt config. I ran the setup wizard a while ago, and that's the package I created. It creates a file called demo.launch. So the command is ROS launch, IRB 2400 Shaun MoveIt config, demo.launch. And it brings up a robot, and it gives you a little marker there. And you can do things like path planning, and you can move robot over here. And in this little GUI down here, you can say plan. And it will take a while. And it will plan. So this is almost amazing if in the end you weren't just moving a robot. But basically, ROS on the fly or through this configuration knows all about the robot to do inverse kinematics, which is not non-trivial. So essentially, if I have a Cartesian pose, how do I get my robot there? And then it knows enough to plan in an environment where it avoids collisions with not only itself, but anything you may tell the robot about. If you are capturing 3D data, it can include that in the collision model. So this is a relatively simple move, right? Because there's no collisions. It just has to avoid running into itself. And for an industrial robot, that's not that difficult. But it's all completely generic. And so you can do the same thing for your arm. Let's see. What else? By the way, this is Rviz. This is a visualization, and there's a panel called the planning, motion planning panel that can be embedded, which is how all this stuff works. So, all right, we'll go for 2 first. Yeah, so if you had, say you could just do a static scan or even a dynamic scan where things were changing. That comes in, and the way ROS handles that is it creates an occupancy grid, and then it uses that occupancy grid to ensure that your robot doesn't run into that. What isn't obvious is what if your 3D data includes your robot, right? So it's actually smart enough to say, oh, subtract out my robot, because you don't want your robot to think it's hitting itself just because the sensor can see it. So it's smart enough to actually pull that out and then say, okay, everything else is non-robot, and that's what I don't want to run into. You know? Yep. We should talk a little bit more detail, but I'll give you the really short answer, which is when you're doing planning in ROS, you're no longer telling the robot how to move, which is how traditional industrial robots have always been programmed. ROS knows what your joint speed limits are. It knows that you know, there are things around you that you don't want to run into. That can be CAD data, it can be 3D data. And it takes care of all that for you. You merely have to say, I want to go, I'm starting at A and I want to go to B, and ROS takes care of everything else. So it's a different programming paradigm. This is a pick and place application. We deal a lot with processes where you actually have a known path. Up until recently, that wasn't well supported by ROS. But we've developed libraries in ROS Industrial where you give that path, but we're doing things like collision checking and singularity avoidance. And so we're, you know, we're handling that a lot better than was traditionally handled on robot controllers. Next. So that's the tricky part, depending on whether it's, the question is, once you have this, which is all in simulation, essentially, right? It's all virtual. How do you deploy that on a real robot? If it's a ROS Industrial robot, we have a fixed way of doing that. So you basically create this, and then you generate a couple more files, and then you deploy a driver for your robot, and it automatically works. So that's for ROS Industrial in the robots we support. If you have a custom robot, the next step is you have to tell Move It how to talk to your robot, your custom robot. And it's different for everybody's robot. Not if they're really awesome and give you that. So the question was, are you replacing software or anything on the robot controller or whatever embedded thing is controlling that robot? And if it's a fetch robot, you're not replacing anything because it's awesome. It already works with ROS. If it's ROS Industrial robot, you are doing a little bit. Some are more user-friendly than others, but that's really a controller limitation. At least in ROS Industrial, we use the robot controllers for what they're good at, and then we do everything else that we're good at. And so it's not replacing one or the other in ROS Industrial. I've seen a lot of people do it. I haven't done it myself, and I don't really understand how to set it up. I understand how to do it for manipulators. I've seen people do it, and there's probably some more information out there. But so the question is if this is the same as using building it in Catkin. A Move It package, so the one I created, has no code in it. It's not built, really. It just has a bunch of configuration files. So in some sense, Catkin doesn't get involved because there's nothing being built. But it is a package because it has data in it. Yes. So a Catkin package can have just non-data or non-source code in it. And a lot of our packages do, because we support a lot of configuration. Okay, so, I mean, what we went over is how to install ROS and how middleware works, how the plumbing within ROS works. And then I know at the end I kind of quickly went through, okay, here's how you stand up a manipulator and get something working visually. There are lots of topics that we kind of breezed through, and some that I didn't even go over at all, but they're all available online. You can also do this stuff using code. So everything we were doing planning-wise, we were doing through a GUI, but there are also ways to do it in code. There are some helpful tutorials for Move It, which is the path planning library that we just saw. And then the final thing I just want to talk about is where do I get resources? rosindustrial.org is a resource for ROS Industrial, certainly, but a lot of things ROS. You can find our training there and our mailing list and source code for our packages, all through rosindustrial.org. If you're just general and interested in ROS in general, so ros.org, you go to ros.org and it has links to wiki.ros.org that has all the package information, has tutorials and links as well. The package wiki, so this is very important. If you know the name of the package you're dealing with, then you can find the documentation. It's just wiki.ros.org/package name. If that's the only thing you learn, that will be valuable. Because you almost always know the package name, because you know what's not working. It says such and such package is broken. You can find wikis that kind of help you work through it. And also find code APIs. If it's a library, it'll have Doxygen generated comments for you. That's really useful. It's in this box here. Everybody misses it. This is a screenshot of a wiki page. It'll have links to the source code. Again, I recommend using Debians, but not source code. But you can get links to the source code. It also has links for bug reporting. This is an open source software. Report the bugs. They're not always bugs, number one, but if they are bugs, you'd be amazed. People fix them. It's incredible and very quickly because we're sensitive about bugs. If you just have general questions, go to answers.ros.org and search and see if somebody had a question. And if not, if you can't find one, go ahead and ask it. There's actually quick responses to good questions. A good question is one where you provide enough detail for somebody to help you. If you just say, I tried move it and it didn't work, that's not going to work out so well. But if you say, I tried move it and here's the ROS package I was using, and it's a ROS Industrial package, I'll get on there and answer your question. All right, that's me again. That's my contact info. I think we're out of time, but I wanted to, are you going to come up, Andrew, and kind of? Okay. Any more questions or? Yep, that happens a lot, especially people who want to go down at the real level. So the question was, how much in discussions with people we work with have people brought up the fact that ROS is not a real-time capable nor reliable transport protocol, really. At a low level, when you care about real-time, 1,000 hertz kinds of things, that can be a real issue with ROS. There are other solutions for that. Rocos is one that we tell people about. In ROS 2.0, I think there's going to be better support. DDS addresses a lot of those concerns. For now, you program defensively in a way where if you drop a message, it's not the end of the world. And you just have to be aware of that. But that is a huge limitation. And on the industrial side, what that means is we have a real-time robot controller, and then we're above that. Yeah. So the questions were, how do I export data if I don't want to use SolidWorks? And there are limitations in URDF, and what is ROS 2.0? The SolidWorks tool is the only one that I'm aware of, although this is a plug. The ROS Industrial Consortium is working on a project to export CAD data in a more easy way. but that stuff doesn't exist yet. So that's the plug. Does ROS 2.0 address the limitations of a URDF? So for example, a URDF cannot, a delta robot or a parallel linkage type robot can't be represented in a URDF. And ROS 2.0 is independent of that. They almost have nothing to do with each other. ROS 2.0 is all about middleware and building, and not so much the capabilities and libraries that would affect URDF. Yeah, come up and see me. I'll point you to the guy who's doing it. Yeah, I don't have a good answer. So the question is, how do you know, this is ROS is really good. It makes the software part easy, but then how do you build a robot and how do you get the electronics? I don't have a lot of experience. I would talk to the fetch guys because they definitely have that experience. You know, our experience is buy an industrial robot because it handles all that stuff for you, and focus on the software, which is what we're good at.
Okay, so now is probably a good time to start. So I have a couple of administrative things, but the first thing I want to do is thank Shaun for an excellent presentation. He's going to be hanging around afterwards, so if you have more questions, you'll be welcome to ask them. So the administrative things, the free lunch, the lunch is outside in the hallway. There are USB keys which you get after you fill out your feedback form. Just cross out somebody else's name on there and put your own name, someone else's name. You hand that over, you will get a USB key with the presentation and some other goodies on it. There are certificates for those of you that like a souvenir, you know, that you actually did at getting started with ROS workshop. There's a table out there. All the certificates are spread out. Just find the one with your name on and take it away. And we are going to be here for another couple of hours at the back of the room for those that want to ask any questions about sensors or anything, ROS, anything that's going on and you'd like to talk about. So I think that's about it.
Thank you all for your time.
Thank you very much for coming.
Thank you.
They were, I mean, I was.
Oh, wow. How come when I did tab it said like 295 or something? Oh, you know what? I have it up. Those are releases, right? Yeah. Oh, yeah. And I probably haven't. Yeah. Okay. That's insane. So did you understand that, like, about OSRF hosting all these packages?
Yeah.
That's, I don't know how important it is for you guys. I mean, you're very capable, but.
So for our robot, we actually built it ourselves.
Mm-hmm.
Like build our drivers, we actually build it on a phone.
Yeah.
And so it's the scripted function. Yeah.
Okay.
And then we load the driver, the driver will put that in. Like, hey, this is well, I'm gonna update the firmware. It actually does call them to go to update the firmware and start the drive.
Okay.
So
That's nice.
Yeah, so the robot, I can basically do update the dev, start the get updated firmware.
Yeah.
So without full out update the robot.
Yeah. We would never be able to do that, like load our own Debians and host our own binaries. So it's really cool that OSRF does that. Yeah. Yeah. I do. Of course I do. Again. Sure. Yep. Yep. So, it's yeah, you're right. Most people they just don't worry about it, but in industrial world we do, right? You know, because like the fetch robot, that isn't going to kill anybody. Yeah, no, yeah, they are, as they should. So here's how we do it. There's the safety layer in the robot controller, and the robot handles all that, and then we put ROS on top. So that doesn't mean you can do certain unsafe things, so you still have to program, or you have to program it correctly. But when you program, like what robots do you work with? Okay, so